Here we have a SAT math question. Okay, let's go the information. Jan is performing an experiment in which she combines potassium and water to produce potassium hydroxide. The amount of water W in milliliters needed to create a chemical reaction between potassium and water can be modeled by the equation W equals to 1.6 times A positive 10, where A is the amount of potassium hydroxide in grams Jan wishes to produce from the reaction. According to the model, what is the meaning of 1.6 in the equation? Okay, so the aim of this experiment is to produce a potassium hydroxide by combining water and potassium. Okay, so now we have to find the meaning of this value 1.6 in the given equation. Okay, now let's go the answer choices. The first answer choice, option A, says an additional 1.6 milliliters of water is needed to react with 1 additional gram of potassium. Option B says an additional 1.6 milliliters of water is needed to produce 1 more gram of potassium hydroxide. And option C says 1 gram of potassium hydroxide can be produced by reacting 1.6 milliliter of water with potassium. Option D says 1 additional milliliter of water is needed to produce 1.6 more grams of potassium hydroxide. Okay, when I go over the answer choices, every answer choice is talking about the amount of water required to produce a potassium hydroxide. So since each option is talking about the amount of water in milliliters required to produce potassium hydroxide, so we have to solve for W in this equation for some value of A, because W represents the amount of water in milliliters. Okay, now let me write the given equation as it is. That is W equals to 1.6 times A positive 10. Okay, so here W represents the amount of water in milliliters required, and A represents the amount of potassium hydroxide in grams. So both W and A cannot be negative. So because they are the amounts of water and potassium hydroxide. Okay, now we have to solve for W for some value of A, because in all the options we have stuff about the amount of water required. Okay, first let me plug in A equals to 1. So A equals to 1 means, so here I'm going to find the amount of water required to produce 1 gram of potassium hydroxide. Okay, now let me plug in A equals to 1 into the above equation. Then I'm getting W equals to 1.6 times 1 positive 10. So here 1.6 times 1 is 1.6, positive 10 will be 11.6. And now let me plug in A equals to 2 into the second equation. So that is, I'm trying to find the amount of water required to produce 2 grams of potassium hydroxide. Let me plug in. So W equals to 1.6 times 2, positive 10 equals to, so 1.6 times 2 is 3.2, 3.2 positive 10 will be 13.2. And now let me plug in A equals to 3. So when I do so, I'm getting W equals to 1.6 times 3, positive 10. So 1.6 times 3 is 4.8, 4.8 positive 10 will be 14.8. Okay, now let's see how the value of W changes. Okay, so here when I plug in A is equal to 1, I'm getting W is equal to 11.6. When I increase the value of A from 1 to 2, that is I increase the production of potassium hydroxide by 1 gram. So the amount of water required increases from 11.6 to 13.2. So it is an increment of 1.6 milliliters, because the difference between 11.6 and 13.2 is 1.6. Okay, now when I increase the value of A from 2 to 3, that is by 1 gram of potassium hydroxide, so the amount of water required increases from 13.2 to 14.8. So the difference between these two values is 1.6. That is the amount of water required increases by the same value, that is 1.6. Okay, so this scenario clearly explains every time when I increase the production of potassium hydroxide by 1 gram, so the amount of water required increases by 1.6 milliliters. So the meaning of 1.6 in the given equation is we need the additional 1.6 milliliter of water to produce 1 more gram of potassium hydroxide. So we find this stuff exactly in option B. That is an additional 1.6 milliliters of water is needed to produce 1 more gram of potassium hydroxide. So the correct answer choice for this question is option B.